That's the full. You're seeing that in the full frame, right?
Yes.
So good evening, everybody. I'm here to tell you about an inadvertent experiment that I did. I've owned a total of 3 mounts in the last 3 years and have run largely the same payload on all 3, which gives me some basis for comparing one to the other. And the purpose of tonight is to share a little bit about my experiences. I can't see any of you or the chat box or anything. So if you have any questions, please just chime in as we go. So let's get started. Start with that thought, which is all over the astrophysics website and has been for a long time. I can't say he's wrong. So here's a recent picture of my rig. The cameras have changed. The filter wheel came along about halfway through the process, but the general approach of 50 millimeter, that's an AP Traveler, 50 millimeter guide scope, ultimate power box. There's a field flattener in there on Los Mandy plates. Total weight's about 22 pounds. I've never fully assembled it and held it on and stepped onto a scale with it because you can see it won't sit on that dovetail plate in its current setup. But when I tally up the weights of all the items, I get about 22, 23 pounds. So not a heavy load for any of the amounts we're going to talk about. So for years, when I bought the Traveler, I bought an Altaz mount with it 20 years ago, and that is what I used until 3 years ago. I just pointed and looked. I went into Starzona, must have been early in the pandemic, and they said you should buy the EQ6R Pro. Great mount, great beginner equatorial mount, could grow with it. I was concerned about its 42-pound weight, and I thought, I don't think I should get anything that heavy. I'll find something lighter. And so what I found was a used Los Mandy GM8 depicted there on the right. Obviously, with the counterweights set before I read about moment arms and listened to Doug talk about them. This was a 2007 vintage. So it was about 14 years old when I got it. It has the one-piece worm block, but not a spring-loaded worm. Few things I really liked about it. Easy to disassemble the whole thing. It's like a 55 Chevy. You could take it down, spread it on the floor of the garage, lubricate it, put it back together. So I really learned at a detailed level, what the different bearings are and how to clean them and how to adjust things. And it was lightweight, 21-pound mount, 5-pound counterweight shaft, so easy to move around. And I found the Los Mandy Gemini 2 system pretty easy to use, and it plays nicely with Nina. There's also, just like our chat forum, Los Mandy has terrific online chat boards with people willing to devote real time and energy to help train a newbie and troubleshoot problems when they arose. A few challenges that I encountered. First, I've got a close-up grainy picture here, but here you can see the motor, the gearbox, and this is the beginning of the worm assembly. This thing sticks out 3 or 4 inches. It is ungainly, and you've got to be careful. Well, I always felt I had to be careful never to lift from it. There are 2 screws that mount the motor assembly into the gearbox. The motor's metal, the gearbox is metal, the gears are metal, but the 2 long nuts inside that housing are plastic. And the mount came to me with one of those plastic nuts stripped. And after some months, I just, the gearbox was like $35. I bought a new gearbox. I could not replace the nut by itself. So that was kind of awkward. And then you can see how the deck cable sticks way off to the side here, and the RA cable is mated to it further down the assembly. Those of you who have Los Mandy mounts, I expect they look pretty much the same. Made it very difficult to, especially for someone new to this sport, to manage the cables without them ever touching, no matter where the mount moved. The other challenge is because I didn't have the spring-loaded worm, there's a little screw on the front of the worm block that you turn, they say, a 1/16 of a turn back or forth in order to tension the worm in back or forth against the gear. It's very subtle. I found it very difficult to do it right. If you make it too tight, the motors would seize, the fuse in a little power control box I had would blow. Too loose, and there would be significant backlash in the deck, significant wobble. And that changed even over the course of an evening with the changes in temperature. So I kept a bag of fuses in the house, and I just lived with the backlash. And, that meant long delays after meridian flips for the motor to catch up to the gear, very sensitive to breezes. It didn't take much for the deck axis to wiggle and give me elliptical stars. Another challenge I had was dealing with the alt-az alignment. The mount comes with simply a bolt and a wing nut underneath it, and the bolt's underneath, the wing nut's on top. You loosen things up a little bit, you adjust your alt or azimuth, and then you tighten it back down. There would be a lot of backlash as you tighten it down. It would reposition the mount. One of the tips I learned from the chat boards was to use Belleville washers to get a little bit of a spring action, and then tighten slowly. And that worked out really reasonably well. For all of these challenges, I did manage to solve. And for a beginner, I created a bunch of images that I was really proud of, at least at the time. Now, I intentionally made these images fairly small because these are all from my first year of imaging, and I wouldn't want you pixel peeping on them because I've progressed a little bit in my post-processing, and I don't think these are great pictures anymore. When the mount was steady, and when I got steady frames, I got terrific frames. But there were nights where I would lose 30–40% of my frames due to wind, which maybe meant I shouldn't have been imaging that night. And if something went wrong, sometimes the motor would freeze up during the evening, and the fuse would blow, and I'd come out in the morning and it would be dead in the water. So great mount to learn on, not one I would have wanted to stay with all my life. So a year ago, after 2 years with the GM8, I had an opportunity to buy a used Mach 1, Astrophysics Mach 1, 2009 vintage, so not terribly different from the Los Mandy. And here you can see when I was setting things up in the garage before I took it outside, significantly more mass, heavier tripod, of course. And by the way, my garage is not this clean. What you are seeing is a result of the wonders of the clone stamp in Photoshop. Here you get a little better view of the mount. For those of you who are not familiar with the Mach 1, both axes here and here are hollow. So you can put a polar alignment scope through here. There's a port on the front, and you can see you run the cables through the mount into the RA axis and then out the front of the deck axis. So here's the power cable for the deck motor, and then you can come out the front, or you can go up to the top of just below the saddle plate, and there are some holes where you can put cables through, and that's where I ran my power and communications cables up to the ultimate power box. All telescope mounts are somewhat awkward in shape, but there was nothing that I worried about grabbing onto when I was moving the Mach 1. It's somewhat heavier, 28 pounds. It does come apart into two pieces. I never separated them, never felt the need. And I was comfortable enough moving it that I would leave the 4-pound counterweight shaft attached to it to move it in and out of the house. I never found the weight to be an issue. Now, I did not use any kind of polar alignment scope. There's the Astrophysics Rapus, the Polemaster. This thing's all aluminum. I would just put my iPhone compass flush against the back of the motor here, get it aligned within a degree or two, and then SharpCap did the rest. Alignment, and this is also true of the Mach 2, which we'll talk about in a little bit. You can see the knobs for altitude here, azimuth here. They're much larger than they were on the Los Mandy, and they move more smoothly with almost no backlash. So it's much easier to make adjustments when you're doing alignment. The mount is very stable. I wouldn't say it had no deck backlash, but it was tiny. So I went from, you saw in the previous slide, with GM8, generally 2-minute exposures was my limit. I could do 2 minutes unguided with generally good results, and guiding, I settled in on 4 minutes, but I could do longer if I wanted to. With this mount, I lost far fewer frames to really none to breezes, and even with a moderate wind, I wouldn't lose a lot. The most important thing is nothing ever went wrong with this mount that wasn't my fault. I made mistakes with the software. I sent it to the wrong place. I didn't check the right box. Never had an accident with anything, fortunately. But some couple of mornings, I found the mount had reached a limit and it stopped. So everything was fine, but it didn't go home like it was supposed to. But it was my fault, not the mount's fault. Now, buying a used mount, it doesn't come with any software. AP allows the transfer of the mount software, but you got to register. You got to go through them, pay them a fee, and register the license with them. So when I was in the process of buying the mount, I debated, do I buy Astrophysics Command Center, APCC, or not? Some people on the Cloudy Nights world said, way too much money. It's $250 for standard, $500 for the pro version. Who needs it? It's ASCOM compatible. Just run with it. They are correct in the sense that you can run this mount without APCC. You can also put Goodyear all-season radials on your Ferrari. So yeah, you can do it. I don't recommend it. The APCC software is analogous to the Gemini 2 software from Los Mandy. It's compatible with Maxim, Nina, the Sky, SGP, other ASCOM compatible tools, and it opens up the full capabilities of the mount. It's very powerful. It's written by a guy named Ray Greylock, who also wrote the software Pempro. His software works very, very well. It tends to have a lot of steps, and I will say it is not an elegant user interface. So that can be a little bit off-putting, and I'll show you some examples in a little bit, but I found that I got used to it. The standard version lets you run everything in the mount except the all-sky modeling. That comes with the pro version. I bought the standard version figuring I had enough to do to learn just this mount and its lingo, and I could upgrade to pro sometime in the future. This was my final mount. it can carry a C11, which is more than I can carry. So I figured whatever I would ever want to do, this is my final mount. And there are a few images that I captured over the last year with it. But then
Hey,
I won
Jeff,
the lottery. Yes.
Jeff, going back to the Mach 1, it looks like you had an awful lot of weight on there for 22 pounds of hardware.
Yes, excellent point. And the astrophysics people, that is what it took to counterbalance the 22 pounds. That's a 14 pound and these are 9s. So that's 41 pounds of weight, which I thought was, I'm sorry, maybe these are 7s. I thought it was ridiculous, but the deck axis is very top heavy. This is hollow. The gear is up here, the motor is here, and then you've got the payload on top. So if you shorten the moment arm to the maximum extent possible, this is what I found it took for the mount to be properly balanced. I mentioned that to George at Astrophysics. He said, that doesn't sound right. So maybe it's a peculiarity of this particular mount. But I didn't worry about it. It worked. So last September, actually, when I owned the GM8, I threw my name onto the waiting list for the Mach 2, just because it doesn't cost anything and I could always say no. I turned down another astrophysics mount many, many years ago. And in September, I received this email. Now, when I say I won the lottery, of course, this is a waiting list, not a lottery. I won the lottery when I got married because I showed this email to my wife rather jokingly, because I had no thought that she would ever give me budgetary authority for something this expensive. And she read the email and asked me what it cost. And she said, I think you should buy it. This is your thing. Do it. So once I got the stitches done on my chin after it hit the floor, I went ahead and ordered the new mount. I did not expect it to be as big a jump as the Mach 1 was over the GM8, because it's kind of a Mach 1A. It's a 15-year more current version. The mounts are not wildly different in size. The 2 has somewhat more capacity than the 1 does. Here's what I found. So here's a picture, a recent picture of the Mach 2 in the backyard. It has a couple of differences. So it doesn't look all, in terms of placement of the motors and so on, not all that different silhouette from the Mach 1. The knobs here are the same size, same fine adjustment, altas and altitude assembly. The big difference is that these axes are not hollow. This is where the absolute encoders are located. And it makes this mount, though it's only slightly bigger, it is about 50% heavier than its older brother. It has through the mount cabling, not that you can control, but they're right in the back here. You can see there's a USB and power that goes into the back of the RA axis. It comes out up here at the top of the deck axis. So you've got one comm line and one power line that you take up to your rig and run everything, which is exactly what I do. These go to the power box, and then the power box connects to everything else up on top of the dovetail plate. So this mount, it also has something I didn't mention on the GM8. The GM8 had setting circles. This has, if you can see them, little notches every 90 degrees around the deck and RA axes. So you can get into a counterweight down position without a level, without any kind of measurement, just align these hash marks and you're done. And similarly, since there's another one down here on the bottom, when I want to balance the scope, I don't need a level to get the RA axis level. I just rotate it 90 degrees. Here's a photo from the star astronomer who did a YouTube video comparing the two mounts. You can see not radically different in size. But this mount weighs 42 pounds. The counterweight shaft is 10 pounds more. So in my daily routine, the counterweight shaft does not stay attached when I have to move it. Like the Mach 1, I find it just easy to wrap my arms around. There's plenty of things to hold on to. I use a camp wagon so that I'm not walking around with this thing clutched to my chest. I just lift it off, set it in the wagon, lay it down gently, and vice versa to go back and forth. I mentioned the absolute encoders. So that means for any newer members of our group that the mount always knows where it is. Because it's tracking numerical coders inside as it moves. It's toggling, reading where it is at a very fine grain, fine resolution. When you buy the mount, an NEAP mount new, it comes with Astrophysics Command Center Pro, which enables sky modeling, which takes advantage of what the absolute encoders can do. And the control box here is, here you can see a little antenna. It's Wi-Fi compatible. I have not yet figured out how to use that because it was just so easy to plug in an internet cable. There is almost no maintenance on this mount. The motor assemblies are sealed and bearings should never need service in the life of the mount. Every few years, it takes a little bit of grease between the worm and the worm gear, and that's it. So what's it like living with a Mach 2? It's great that it always knows where it is, unless you lie to it. If you point it at Aldebaran and you tell the mount it's pointing at Betelgeuse, it's going to be lost. But otherwise, those encoders always tell it where it is. I could get everything aligned, point at a target, loosen the clutches, turn the telescope upside down, reset the clutches, go into Stellarium and click go to the same target, and it would do it. This mount is extraordinarily stable. Certainly the extra mass helps. There is no deck backlash at all. So I'm losing less than 2%, usually a few images a night to wind. Now I've been shooting 25-second exposures of M42 the last couple of nights for a couple hours at a time. So I've collected, I think, 1,000 subs over 3 nights. I'll lose some frames to clouds because of these gauzy clouds we've had, but not one due to mount wobble. You may remember I posted some questions about how long subframes can and should be on our chat. I don't think there's really any practical limit to how long I could make guided subframes. I've been using 4 minutes, or at least I did until I saw the video that Quiv posted this week that you don't need darks anymore just because your bias frame signal swamps the dark noise. Because of the absolute encoders, there is no periodic error. There is no periodic, I'm sorry, I shouldn't say there's no periodic error. There's no periodic error correction to do, so you don't have to do PemPro curves. Out of the box, I was getting guiding, as you see here, which I think by all accounts is very, very good. It's similar to what I got with the Mach 1. just a week or so ago, I built a sky model for the first time because I hadn't learned to use it, and it was purely a test to see what would happen. So I ran what they call their small sky model, 30 points in the sky. And then I forgot about it. And the next night I set things up. I'd left the mount out overnight, and I turned on PhD2, and you can see how my guiding results changed. It takes about 15 minutes to build one of these 30-point sky models. I've been in touch with the AP folks a little bit. I have not tried what's called deck arc modeling, which is, instead of an all sky model, you take 3 lines of declination, your target line, and 1 degree above, 1 degree below, and you take lots and lots and lots of images. So you get a very granular read of the arc you'll be working in for the night. It's supposed to be a superb system. If I'm getting this kind of guiding results, I'm not sure I'll ever bother with a deck arc model. The support from Astrophysics, they're legendary for it. Both the company itself and the chat boards. I've posted questions at 5:30 in the morning, and I get response from Roland Kristen within an hour to the question. And they're honest people. When I was debating which accessories to order with the mount, I got on the phone with one of the guys, and he basically said, you need counterweights. And beyond that, you really don't need anything else. And a saddle plate. I mentioned the software a little while ago and what APCC can do. Due to the geometry of AP mounts, because the RA axis sticks forward so much, at certain declination lines, the mount can turn upside down safely and can swing through almost 360 degrees. So here's a picture of my mount that I took just to demonstrate it. You need APCC to take advantage of these features, because you have to have settings which will tell APCC when it's safe to rotate around and when you're going to ram your camera into your pier or tripod. I'll show you an example of that in just a minute. One nice feature of APCC is what it calls the 3D view. You've got a number of different views: top, north, south, east, west. This is the trimetric view that shows your telescope and what position it's pointing at. Real time, when you click slew, you see this little cartoon telescope move right along with the mount. So it's great if you set up outside, get aligned, and then go inside. You can see where the telescope is at all times. You can configure the telescope. You can choose refractor, reflector, SCT, the diameter of the tube, the length of the tube. So I've created one that sort of parallels what my telescope looks like. One other tip that I learned. The Mach 2 and all AP encoder mounts come in 2 flavors: regular and extended temperature. And according to the website, extended temperature encoders are for use in temperatures below 0 Fahrenheit. So when I was talking to them, I said, gee, in Tucson, I assume I don't need extended temp encoders, but we get down into the 20s. And he said, oh, good heavens, we've run the standard encoders down to 0 Fahrenheit without any problems. So, I guess the extended encoders are for people way up in the mountains of Colorado or Chile or something like that, where it gets extraordinarily cold. So what's the challenge with the Mach 2? It's lots of wonderful stuff. There are a lot of limits in the Mach 2. Plus, of course, you can have limits in your imaging control software. And I found it a bit challenging to get all these limits configured so the mount wouldn't do something crazy. Now, again, whenever it did something crazy, it would either stop or it would go home. I never had any risk of anything getting damaged, but at the beginning, I would come out in the morning. My last command is go to what AP calls Park 3, which is counterweights down, and the mount would be pointing off someplace else. Like, okay, what the hell's happening? So home, the Mach 2 has a concept of home and it has park positions. They're not the same thing. If the mount gets screwed up for any reason, like in my example with Betelgeuse and Aldebaran before, if you click the home button, the telescope goes home, which I've programmed. It's generally, actually with the Mach 2, it is the Park 3 counterweight down position. That puts it back to, resets its sense of where it is, and everything's fine from there. What I discovered is that Nina has a find home command and a park command. I thought, cool, I can use one or the other. The Mach 2 does not respond to a home command. There's some ASCOM setting that is turned off on the Mach 2, and I think the logic is that home is for solving problems, and you should use park positions. So I found, and bear with me down a rabbit hole here, if I home the mount, and I'm going to jump ahead a slide and come back. Oops, no, I didn't keep that slide. When you unpark a mount, the default setting is to unpark from the last place you parked it. So if you're always parking at counterweight down, it unparks from counterweight down, which tells the mount where it is in space. If you unpark after homing it, Nina didn't seem to like that, and it would try to send the mount home instead of to Park 3 counterweights down. So what I've learned is, if I need to home the mount, I home it, I unpark it, then I park it to Park 3, and then I unpark it again. And now it's unparking from a park position, and everything works fine. Limits. I mentioned, I was showing you the picture a moment ago of the telescope being upside down. This is how it is able to do that. They're called meridian limits. For different declination lines, you move the mount, different RA lines, you move the mount, swing it around in declination, and stop it when, in your worst case scenario, when the telescope starts to get close to a pier or a tripod or any other obstruction. And you should do it in your worst case scenario. So I would keep turning my filter wheel, since it's off axis, inward toward the mount, so that in the happenstance where the filter wheel was turned all the way in, it still wouldn't hit anything. So you can see the results. There's a little program you run through to create a program like this. It took me about 45 minutes. You can do one side and mirror the other. I went through the exercise and did both sides. So it's about a 40-minute exercise. But now the mount knows where it can swing wide, which is these areas down here, and where it has to stop as it approaches, like straight up at the zenith. Of course, the scope is going to hit just about any pier or tripod. So to me, this is one form of safety limit. This is what I guess you'd call the internal safety limit. And then there are horizon limits, which will stop the mount from going below the horizon. For reasons that I can explain over a beer separately, I do not use the horizon limits in APCC. I've just set it at a low number. The telescope, I figure, shouldn't be pointing down below 7 or 10 degrees. And if it is, then something's probably wrong. And you can see here, if it hits that, it will park the mount. Now, I have run into this a couple times when I'm slewing, where it has started moving in RA. The mount, the objective is pointed, say, to the west. It starts slewing west, and the objective points down. Boom! It stops and goes home. So I'm learning how to deal with that. I do use horizon limits in Nina more so I can plan my when to stop a target, when to pick up a target, than to actually use it as an actual limit. And then the encoders have their own limits. You can toggle RA limits, deck limits on and off. I read the manual, I turned them on, things were going haywire. And when I talked to the support folks at AP, they said, for your purposes, you've set the meridian limits, just rely on that and the horizon limit and turn these off. So I don't use the RA and deck encoder limits. Not a ton of pictures. I've only had them out since October. But a couple things that I have found with this mount. I used to use eccentricity as one of my basic measures in subframe selector. Unless there's a good gust of wind, all my stars are below the eccentricity that I can detect with my eye. So it's no longer a useful measure for me. I mentioned I've been experimenting with the all sky model. I have not used my guider now in a week. I do not see any difference in my results with PhD2 turned off. And when you do use PhD2 with an encoder mount, you do what they call bump guiding, where you set the exposure at about 4 seconds. So it's really only there to give it a little bump back into line if necessary, so that you're not, because it's not the primary method of guiding. So what mount will be next on my in my plans? And I think I already own it. This is a little post that Roland Kristen made just yesterday. That's a Mach 2 in Rockford, Illinois, so we're outside of Chicago. He was running it at about 16 below 0 Fahrenheit. That is a 305 millimeter f3.8 Riccardi Honders astrograph that weighs 75 pounds. That exceeds the stated limit of this mount. And he reported the mount moved that telescope around like there was nothing in the saddle plate. The temperature had no effect on it. The temperature had a lot more effect on him than it did on the telescope. So it's pretty inconceivable to me that I would ever think of a different mount. So that's the journey that I've been on, and it's been great fun, and I'm happy to answer questions. Here I will give you these closing thoughts, which I think I've covered. So there we are.
So, Jeff, I have a couple questions.
Go for it.
So just out of curiosity, I mean, I think we've all grown up with sort of the meridian flip regime, and this weights up kind of paradigm seems a little scary to me. How have you found the weights up? I have this nightmare of weights coming crashing down into the OTA, because those screws don't seem like they're terribly stiff, but I'm just curious if you've run it in the weights up configuration, how, if you're satisfied.
I have not done it on purpose. And the idea of using counterweights up is that you avoid the meridian flip.
Right. No, it's a great idea, but I'm just afraid to do it.
So my dog woke up at 12:30 the other morning and had to go out. The mount was running outside, and it happens at the moment to be set up near our back bedroom door where I go out in the middle of the night. And I had my little red flashlight on. And I just noticed I was shooting M42, so the target very high in the sky. The mount was in about the position that I showed you in the daytime photograph. And I kind of looked at it, half asleep, and said, "Oh, that's cool." I don't know if it ever did do a flip. I suspect not. I think it probably just finished out that target because my house is to the west, so I can only get to about 45 degrees down from the zenith in the west before I'm looking into the house.
I mean, there is no reason
I can tell you the counter when I came up out the next morning, it was counterweights down, and the counterweights were down where they belong.
Okay, yeah, that's good. So I have another question about your PhD comments. I think I've talked to you about this before. One question is about if you're not guiding anymore, what are you doing about dithering?
Nina has a product or a feature called Direct Guider. It's a ditherer.
Oh, okay. So that's what
turn
you're
on
doing.
the Direct Guider. You connect Nina to the mount and specify how often you want to dither, and every X frames it dithers.
Okay, interesting. So you are potentially still you're drizzling with the results, or no?
Yes.
Okay, great.
Although this is all of a week old, I've got data that I haven't processed yet.
Yeah, fair enough. And then I still think it's a good idea. I wouldn't give up on your your guiding entirely. I would just turn your corrections all the way off and turn your guider into a seeing monitor. I think that's
well, yeah, you emailed about that, and that's so. I did try at one point setting a custom exposure time. I think the most you can do is 30 seconds, which gave me huge blown out stars. And that didn't seem to accomplish anything. But I guess what you do is you just lower the aggressiveness on the guiding to 0.
Essentially, or 1. I mean, anything. I don't know if they let you go to 0, but you can go to a very small number and then go to the fastest images that you can take. I think you can set up for either quarter second or half second, and that would be a pseudo seeing monitor for you, just for grins. I'll try that with my mounts as well when I get a chance.
I will.
Poor man's seeing monitor, yeah.
I'd love to see what that would give me. So low aggressiveness and and fast exposure.
Yeah. By the way, congratulations on your cable management. Even on your old mount, I like that cable management. That's nice and clean.
Well, thank you. Thank you.
I have
Go ahead, Randy.
I have a suggestion. I know with just my EQ6 now and then you have the nightmare of it does get tipped a little bit, weights up, and all that come crashing down. I have added some, there are collars, and they're like, you can buy a set of 4 of those collars for $20. And I have my weights collared on both sides. So, and these are very secure. They adjust. Each collar is a 2-piece thing, and it has 2 Allen screws that hold them together. So they're very secure. And now there's no way those mounts or those weights are going to move either up or down, no matter what configuration is in. For all we spend on this stuff, $20 to eliminate that risk is well worth it. They come in different diameters, so you can match. You should be able to find some that match your counterweight shaft size. But on the EQ6, it happens to be 18 millimeter, I believe. Anyway, but that's a very effective solution.
That sounds like a perfect solution. I'm thinking now, with a setup like the one that I depicted, where I'm keeping the moment arm to a minimum, so the counterweights are basically at the along the bottom of the deck axis as it is. I've got very, even if those things came unglued, they're not going to hit the telescope. I suppose when the mount goes home, then they're going to slam down to the other end of the.
Yeah, it's just them slamming one end or the other of it.
Yeah. Yeah.
But again, it's just an easy way to fix that possibility so they can't move. And they were since they're two-part,
Right.
you don't have to remove any weights to put these in. So if you need to make an adjustment in where the weights are, it's very easy to back these off and then just move your weight and then put these, just snug these up again. And they're not going to move. So
Yeah, Randy, you might post a link to those things.
I was just going to suggest that, Randy. Why don't you post a picture and a link to show everybody what you got, because that sounds like a great idea.
okay, and I picked it up. It was on some YouTube video. That's where I had got the idea. But anyway, the other question, Jeff, if you don't mind, what was the all-in delivered cost for this mount?
With tax and shipping, I think it was 12.1, 12.2. I think the mount's 11,190. $285 for shipping. I ordered a saddle plate and 2 counterweights. So for this one, because the mount is so much more solid, I've got a total of 28 pounds. They said 90 to 125% of your payload weight in counterweights.
You already had the tripod. Is that right?
That's the same tripod as I was using with the Mach 1, and I kept it. It's one that Astrophysics sells for the Mach 2, and I figured,
sure.
Why? There's another thing that they talked me out of. I said, should I buy an Eagle? And they said, Eagle's really nice, but you don't need to spend the money.
Yeah. Okay.
Jeff, could you address the issue of why you didn't buy a hand control? Was it?
All I'm doing is imaging. And so I run everything through the computer. Now, I did try once with the Mach 1 to have a colleague of mine come over. That really doesn't work well to do visual and control with the computer, because there's a little tool for jogging the mount a tiny bit in different directions, but it's not the same as pushing buttons on a keypad. So if I got serious about visual, I would buy the keypad.
And the keypad's about what, $1,000 more, $1,500?
Oh, I think retail's like 13, 15.
Yeah.
It's kind of like going to a very high-end car dealer. If you're going to do it, you just don't think about the price.
What's the most obnoxious thing is the counterweights. I don't mind paying for a mount with encoders, but I hate paying so much money for counterweights. It's just a block of steel, So
I'm with you,
that's
Doug.
ridiculous.
It's a crime.
It is a
Very,
crime.
very nicely polished, to be sure, Doug.
Yeah, sure. They're beautiful, but
Ridiculously priced.
it's ridiculous.
Yeah, they're expensive. And I
Hey,
was
just,
not able, the Mach 1 has a 1 1/8 inch counterweight shaft, and the Mach 2 uses the bigger 1 7/8 inch shaft. So I could not use any of my old counterweights on the Mach 2.
Yeah, so
I'm
that
sure
means
some
I don't
things
think
are-
we're going to be able to get a $20 collar to protect those weights. But but the idea is still great when you consider how much money is being protected from falling down on that telescope, or or to the Park 3 position. So yeah, still a good idea on the collars, but probably gonna have to
Yes.
spend more than $20
Maybe 30.
because of that shaft, right? Yeah.
Yeah.
One other comment, Jeff. I had a little, after when you got this, I said, well, maybe I should get on the list and look at this. I did get on the list, but one thing I have learned is if you are addicted to the ASI air, at best, you would only get marginal usage of what the scope can do.
Right.
Yeah, so if you're an air user and you don't want to switch to Nina or something like that, it probably doesn't make sense to get this much of a mount and then not get all the features that it can deliver. So just
Makes
for what
sense.
it's worth.
Have you considered
Jeff, when you set
sorry.
when you set it up with the meridian limits, as you showed us on APCC, Does Nina use those, or does it have its own sets of limits?
Nina does not have its own meridian limits. The mount has the meridian limits. Nina can read your, if you use a horizon file in APCC, you can point Nina to it, it'll read the same file.
So I guess my question is, if you have the scope set up in such a way that it doesn't need to do a meridian flip, it won't do it. It'll just track past the meridian.
Right. And then you can also, this is a feature that they tell you should be present if you're going to do it. You can start the telescope upside down early in the evening.
Yeah, well, I'll give you some history on that. I have a couple of AP mounts that are really old, and they started out with what they call meridian delay. And it was built into the hand controller. And you just punch up, you know, I want to go 3 hours east of the meridian and turn the damn thing upside down. And, you know, it was before APCC, and you damn well better be there when it got to the meridian, because if you had not measured everything just exactly perfectly, something was going to run into something else. But they did have that, you know, 15 years ago, and they called it meridian delay.
Well, and within APCC, they still use the concept of meridian delay. You don't have to set it per se, but it reports what the current meridian delay is based on your meridian limit. So you might have, you know, depending on what deck line you're on, you might have an extra hour or 2 hours. But I use the smart meridian flip that Dale Gent created for Nina as one of the astrophysics tools. It just reads off the meridian flip as to when it needs to flip, and it flips, and it has been completely flawless.
It decides that based on that meridian map that you created?
Yes. Yeah, and the key is to be careful creating that map.
So you mentioned it takes about, you said 15 minutes or so to run a 30-point model.
Yeah.
Have you tried to run an even larger model? Don't they recommend like a 100-point model for a
there's a
setup?
small, medium, large, and for all sky models. And they say for the large all sky model, which could be like 300 or 400 points, that's really best for a permanent installation. I never dreamed that the small one would do me any good, but I got these results. I repeated them the second night. I posted on the AP mount board, and Brian Valenti at Astrophysics said, yeah, with 660 millimeter focal length, that's probably going to get you a significant improvement.
Interesting.
So I will try. You know, I love the idea of getting a model done that fast. You know, even in the twilight, when you can get your autofocus done and then run this mapping before you actually start imaging. But I will experiment with the deck arc model. The deck arc model only works if you have a single target all night. If you have 2 targets, you know, you can only have one deck arc model at a time, right, unless they're very close in declination, and you can build a slightly wider model, I think.
Have you found that that it helps? I mean, when I think of a model like that, I think for pointing. I don't think necessarily for guiding. But it sounds like you've achieved both. That your slews are better on target, and the guiding is better.
Absolutely right. I now sync on a single star, and I'll use Nina. There's a pull down list of bright stars. I'll go to the star, I'll solve it, sync, and recenter. And then after I've done my autofocus, I send it to my target, and this week it has been dead center, no adjustments.
That's good to hear.
The modeling is interesting. It shows a difference between the predicted RA index and the actual RA index of up to like 25 arc minutes. Thinking, God, that's like the diameter of the full moon almost. But I guess that's atmospheric refraction, largely, and then other factors. But the difference has just been stunning.
Good
since
deal.
I started doing it.
Yeah, Jeff, with the deck arc model, you can actually set up a fairly wide deck arc
Right.
model. In other words, you're not necessarily limited to say a 2 or 3 or 4 degree north-south deck band. You could set up, let's say, a 10 or even 12 or 15 degree band in declination and have it run from a portion of the eastern part of the sky all the way down to your limits in the west, and just populate it with a adequate number of data points, and it will work quite well.
How long does something like that take, Tom?
Well, I've done a bunch of them, and it depends on how many data points. As you know, the time goes up rapidly with the number of data points you put in
Right.
there. But if you do something like 50, I'm saying about maximum, really, for say going from the meridian all the way down to your, say, western altitude limit, and you have a band that's roughly 10, 12, 15 degrees in declination, that will take roughly 40 minutes, 45 minutes maybe at the most to do that model. And it gives amazing accuracy. And it's really handy, especially if you do a little planning, and maybe during the course of a night, you plan on imaging 2 different objects, and they both fall within that
Right.
model you create. Then when one gets down to your altitude limit in the west, maybe your other object then is just coming up toward the meridian. You can pick that one up and image that, the rest of the night.
Right.
So you only need to make that one deck arc model, or you can make 2 smaller models and just jump from one to the other when the object that matches the particular model you have comes up.
Although that requires being awake at midnight, right?
Yeah, that's a disease some of us have.
All right, let's not give too much of that away because we're going to discuss this in the near future. So, but yeah, I think that's a good point that you're making, and we'll talk about this more next month.
Yep.
All right, is there any
Greg,
any
are you
other
going to do
comments or
another?
questions?
Are you going to do another program about mounts?
No, deck arc modeling.
I ask because I have the new Rainbow Astra and super mount tripod.
I'll take this as that you're volunteering to do a review for us.
No, I'm still learning to use it.
Okay, we'll give you a month or 2. How's that sound?
Vince, it didn't stop me. My mount arrived in the middle of October, late October.
Mine got installed about a week and a half ago.
Well, then I think in fairness, Greg, we probably should let Vince wait till March.
Yeah, but that's great. We're always looking for additional topics, and particularly stuff like mounts or filters where, it's of interest to almost everyone. So I'll keep that in mind, Vincent.
I am just finishing building an observatory here, and I've set up my C11 and my C14, and last night was the first night I actually had both telescopes shooting, and both of them I still need to do work with the guide scopes. So a lot to learn, and it seems like there's always something new to learn.
It never ends. That's the joy of this hobby, right?
I'm about to ask my wife if I can buy one of those astrophysics mounts so I can videotape her reaction and show it to everybody in our next presentation, if you like.
Well, you just got to pick the right wife, I guess.
This is my second wife. I don't want to have any more.
You might be surprised.
The one argument that I made is, these things hold their value.
Yeah.
This is not an expenditure. It's not like buying a car that's going to depreciate so dramatically.
Actually, I was not even planning to get into this hobby at all. A year ago, my wife just suggested, instead of buying gifts for each other, why don't we buy a telescope? And she was thinking like, okay, well, look at the moon and stuff like that. I think I looked at the moon once, and then I looked at Saturn. I thought that was kind of cool. I said, okay, I've had enough of that. Now I need to get the camera and get that set up. But it's been quite a ride for me. But yeah, for me, the AVX is the mount that I have, and I'm learning how to use it. And I could see in the future getting something like an AM5 or something. But for right now, I'm just trying to learn what I have before I expand
Well,
it.
while you're at it, you might throw your name on that waiting list because I think I waited 2 years.
Really? Wow.
Some AP products are lottery, like they're 110 millimeter refractor, but the mounts, it's just a waiting list, and I guess they get to you eventually.
Wow.
My neighbor just passed and he had 2 of them sitting out in the yard in front of me. And his wife tried desperately to get me to buy them. But I
Sounds like a
like
good
my
idea to me.
I like my ASI Air.
Yeah.
Hey,
Here's-
well, Jeff, thank you for leading that discussion. I think there's a lot of good information to share here.
You're welcome.
Any
Thanks
other
for the opportunity.
questions? All right. Well, we're about at an hour, so if there aren't any other questions, we'll call it for this month, and I hope to see you all again next month. We're going to talk about a related topic, and I'll post some information about that shortly. But again, I'll try to have this recorded and uploaded so that you can review it if necessary, or for those who didn't get a chance to join us, they'll be able to get to it. Thanks,
Greg?
everybody.
Take care,
Greg?
all.
Bye, everybody.
Thank you.